So good morning, everyone. Today we are going to see the compiler design in Unit 1. So before going to see what is compiler design, what is compiler, right? Where did you use the compilers in C and Java, C++ in programming languages, right? So basically what is compiler? What it has done? Okay, so when you are just compiling your program, just directly you are executing. If your program has any errors, directly it is returning the errors, right? So what job it is done inside. So that designing we are going to see in this compiler design. Okay, so before that you must know what is compiler. A compiler is a program that translates the code written in high level language into it converts into a machine level languages. So that is low level languages. So here the basic design of the compiler, you are giving the source program to the compiler and it is returning target program, right? So it is normally it is in high level language. This source program which is written in a C, C++, many languages you have, right? So the target program is low level languages, that is machine understandable languages. If it has any errors, it returns the error messages. So that is the basic job of our compiler. So compiler design its principles which provides a in-depth view of translation and optimization process. So it covers the basic translation mechanism and error detection recovery. So it includes like lexical syntax, semantic analysis in the front end. So these all things we are going to see in a phases of a compiler, right? So the high level language is converted into a binary language in various phases. Okay, so these all the different phases we can discuss in the other sessions. A compiler is a program that converts high level language to the assembly level languages. Similarly, an assembler is a program that converts the assembly language to machine level language. So let us first understand how a program using C compiler is executed on a host machine, right? So user writes a program, suppose it is in C language, that is high level language. Then the compiler compiles the program and translate it into a low level language, that is assembly level program. Okay, so that an assembler then translate the assembly program into the machine code, that is object code. A linker tool is used to link all the parts of the program together for execution. So that is executable machine code. A loader loads all of them into a memory and then the program is executed. So we have a major parts is analysis phase and the synthesis phase. So before going to the concepts of a compiler, so we should understand a few other tools like we have preprocessor, interpreter, assembler. Okay, linker, loader, cross compiler, source to source compiler. Okay, these are all the tools we must know. So what is preprocessor? A preprocessor generally considered as a part of a compiler. It is a tool that produces input for compilers. It deals with the macro processing, augmentation, file inclusion, and the language extension, etc. So what is interpreter? This is the another tool. An interpreter like a compiler translate high level language into a low level machine language. Then the difference lies the main difference lies in the way they read the source code as input. A compiler reads the whole source code at once, then create the tokens and check the semantics, generates the intermediate code. It executes the whole program and may involve many passes. So in contrast, an interpreter reads a statement from the input and it converts it into a intermediate code. So it then executes it, then it takes the next statement in sequence. If an error occurs, then the interpreter stops the execution and responds for it. So whereas the compiler reads the whole program even if it encounters the several errors. So we have another tool called assembler. So the assembler translates the assembly language programs into the machine code. The output of an assembler is called an object file, which contains a combination of machine instructions as well as the data required to place these instructions in the memory. So the linker is a computer program that links the merges various objects files together in order to make an executable file. All these files might have been compiled by separate assemblers. Then the major task of a linker is to search and locate the referenced module routines in a program, and then it determines the memory location where these codes will be loaded, making the program instructions to have absolute references. So what is loader? Another tool is called loader. So it is a part of operating system and it is responsible for loading executable files into a memory and execute them. It calculates the size of a program, that is instructions and data, and creates memory space for it. It initializes various registers to initiate execution. So another tool is also called cross compiler. It is a compiler that runs on platform A and it is capable of generating executable. You can execute this code on another platform called B. So this is also called cross compiler. So last tool is source to source compiler, a compiler that takes the source code of one programming language and translate it into the source code of another programming language, and it is called a source to source compiler. A compiler can broadly divided into two phases. See here, we have a major parts here. First one is analysis phase and the synthesis phase. It is analysis phase. It is also known as the front end of the compiler. So we have two ends, that is front and back. So first front end of the compiler is also called analysis phase of the compiler. It reads the source program, divides it into the four parts and then checks for lexical or grammar and syntax errors. These analysis phase generates an intermediate representation of the source program and the symbol table, which should be fed into the synthesis phase as input. So when all these analysis phase, once it is done, then this output is going to become a input of this synthesis phase, right? So what is synthesis phase? What is synthesis phase? These all the stages, these all the phases comes under in the synthesis phase. That is back end of the, you can call it as back end of the compiler. It is synthesis phase, so is also known as the back end of the compiler. The synthesis phase generates the target program with the help of intermediate code, representation, and the symbol table. So we have two types of here, that is pass and phase. What is the main difference of pass here? A pass refers to the traversal of a compiler through the entire program, and a phase of a compiler is a distinguishable stage which takes the input from the previous stage process and yields output that can be used as input for the next stage. A pass can have more than one phases, right? So this is the main difference between the pass and the phase. So next we are going to see what are the phases of a compiler. So till now, what is that? What are the two types? That is what we have, analysis and synthesis phase. So these all comes under in analysis phase. This backend is comes under in synthesis phase. So this we are going to discuss in the next session. Thank you for listening.